Around 6 years ago, on a Sunday night, I was doing a deployment that had a very small feature that I was upgrading. Now, because we had a CI/CD system that I really believed in and it was reliable, I decided to do it on that Sunday night. Now, it was important to do so because on Monday morning, we were going to have a press release early that day. Now, I should mention it's early, like developer early, so it was 9 o'clock, but I didn't want to get up that early, so I was going to do this all Sunday night. So I go through our standard process, which is a CI/CD process. I go ahead and build the project, run through its unit tests. We had very good coverage, around 90%. From there, it would then build and then get out to a QA or a staging environment. Now, I was also the QA team, so I would go ahead and test it and run a integration test suite that we had against that environment. And if you're anything like me, in the last 20 years, I've never had a single kind of like amazing integration test suite, but it was good. Yeah, there were some few tests that were flaky, they would fail, but you would kind of move on because you're like, oh, those are the ones that always fail. So you're like, whatever, let's go. I also verified it on stage that I was gonna, that these pieces of functionality would work. So then I passed all the tests, decided to go to production, just went ahead and deployed it. But I'm not a crazy person. I just put it onto like one machine, then scrambled over to Datadog, looked at the metrics. I was like, this seems about right. In fact, actually, I remember that the metrics looked even better than what I had expected. The CPU was down a bit, the memory footprint was down a bit. So everything looked great. I then finished rolling out the deployment to 100 or so servers. And then from there, I went to bed. Pretty simple. I put my phone next to my bed and then went to bed. So then I can remember just the slew or the onslaught of text messages that would wake me up. The phone was just buzzing nonstop. I woke up and they were begging me to get online. As I looked around, the press release had gone out well. We had gotten a bunch of traffic, went to go look at the metrics. They seemed to be holding true and everything looked great, but there was a problem. And that problem was that users weren't being registered, which was a big problem because the whole press release was around trying to get users to use our service. And if they can't register for the service, they can't use the service. And so as I digged into the code, I realized what had happened. There was some branching logic that meant that about 30% of the users who selected a particular option were not actually being committed to the database. Their profile images were not being uploaded and emails were not being sent out for their registration, which accounts for the actual dip in CPU and memory. So it wasn't actually my fantastic code that I was writing. It was indeed this computer doing less work. So going through that, it was fairly embarrassing. I tried to do the best I could, and I still didn't come through when I could have. And really, when we think about and I look back at those mistakes, there was three mistakes. I ignored the flaky integration test. It was not actually a false positive; it was a true positive that time, and so it was truly not working. The second thing was I succumbed to the business pressure of me having to get this feature out because the next day was going to be a big day and a big release, so I had to get this thing out regardless of any yellow flags that came out. And then the last thing, I mistakenly thought that an improvement in the CPU and memory footprint were my doing in terms of the code that I was pushing out. I tried to make it kind of these pieces connect, but it was trying to put a round peg in a square hole. Right. So these are things that we all kind of go through, especially early in our career when there's just a lot of pressure to get things done and we don't let computers do what they're meant to do. Right. Which is centered around automation. And there was a lot of manual steps and things that had to get done in order to get this code out. But that really shouldn't be the way it's supposed to be. Now, if you look at any software delivery pipeline, there's really one goal and one goal only, which is to reduce risk of getting code out the door. Every single step that goes from after you've done the feature to into production is all about reducing risk. So if you have to go through a security assessment or upgrading the ServiceNow or a Jira ticket is really all about reducing risk, right? It's all about making sure that you're confident in the code that you created is important to go out, that isn't going to fail when it goes out. And when we think about risk, we got to first define risk. So what is risk? Risk is the probability of failure multiplied by the impact of that failure. Now, we spend most of our time reducing the probability of failure. Think about how many times you've pushed code out and someone just comes back and says, oh man, we should have caught that one. Oh, we should have caught that one. Now, if you think about all of the ways that your code could fail, you would be writing integration tests non-stop because they're hard to write, they're hard to maintain, especially as you scale and grow them, right? So the answer cannot be reducing probability all the time. Instead, what we need to shift our focus on, especially as software gets more complex, into reducing the impact of that failure. The result will be the same in terms of risk, but we'll be able to do it at a much lower cost. And so what can we do to reduce impact of failure? Well, we're doing it already as an industry. The idea of moving into microservices is that if a service were to fail, right, 1 out of 1,000 services or 100 services is reducing the impact. Also, think about things like feature flags. That's about testing something in production, making sure that the impact is low. Same with chaos engineering, and of course what we're here to talk about today, canarying, and canarying with Spinnaker in particular. So what is now canarying? So canarying is made up of two things, orchestration and the analysis. And we do this, everybody does canarying, except that we're doing it all manually, right? We deploy manually onto that machine, we scale out manually, we then do the analysis manually. And that opens the doors for all of the biases and all of the things that we are trying to accomplish to get in the way of a technical process. If you think back to what a technical process should be, it should be no psychological component to it where a human being has their fears and anxieties about deploying something in production. We all have it, right? That should not be weighed into the situation, but it is, because humans are the ones controlling these machines in order to get your code out the door. So the more automation we have, the more that we're going to make better decisions without our psychological biases of fear or business pressure or that VP that's telling you you need to get that feature out the door. We can make decisions that are based on data and truth and analysis, right? And so we'll go into that today. So let's take a look at what orchestration looks like inside of Spinnaker. Okay, as we look at our pipelines inside of Spinnaker, we're going to show you what the orchestration side looks like. The first is the configuration. This is where you can set up your triggers or any parameters that you want to be as input as part of this deployment pipeline. Now for today, for our demo, we are not going to do a fully automated pipeline, but you would want to have something trigger off of for, say, GitHub or Jenkins, or maybe some other pipeline completing, or a webhook, or even pushing a Docker image into a Docker registry. So we can support all of those things. The next step is getting info and deploying the service monitor. Now, I'm going to stop right here because I think it's important to denote why we use a different way of deploying canaries. Now, the way that we deployed canaries manually is we go, okay, we're going to deploy this one server and compare it to 100 servers. Now, while that works, it's not really scientifically accurate. What we're going to really want to be able to do is to set up a true experiment. Now, in order to set up true experiment, you need a control group and a group that's going to be experimented against. And those groups need to look exactly the same. So our process today is to grab the image from production that's already there and then duplicate that by deploying a new replica set or a server group or an ASG, whatever it may be, into production. So if you had 100 servers, you're now going to have 101, where that 101st server looks just like the other 100. We're also going to deploy our experimental group, which will have another one right next to it. And so now you'll have 102 servers. You have 100 of the regular, what's in production, then also the baseline or the control group, and then of course the experimental group. So we're going to get what that image is in production. You can see that we are finding an artifact or a resource from production. Here we're also deploying out a service monitor so that we can use Prometheus to loop back metrics into our analysis engine. It should be noted that we can actually support many different types of metrics providers. So Datadog, New Relic, we're using Prometheus, Signal Effects. So there's a bunch that we support, and we're always supporting new ones. From there, we evaluate some variables that we'll use later on. We're essentially extracting out particular strings from the artifacts. We'll deploy our baseline in our canary. We'll do then the canary analysis. We'll provide a manual judgment. We still, at first, want the human in the loop to be able to make decisions. And then at the end, what we will do is destroy our canary, destroy our baseline. And if this is a good deployment, we'll promote it to production. So let's look at what our clusters look like right now. So we have a few versions here. We have 4 pods that are running in production. You can see when they were created, August 20th. And what we will do is then kick off our pipeline. Again, ideally this is kicked off of some sort of automated process or some sort of trigger that comes from a previous process, so you can link these processes together and have them be automated. So we went ahead and got our artifact from production. You can see that it's just this hello world container. We also pulled out the current image, which is Tuesday. The new image is going to be a Saturday. And as we go into deploy baseline, we've gone ahead and deployed the baseline and deployed the canary. Those are green. All of those are just deployment manifests. And you can see here soon they will start to come up, and we'll be able to view them from our clusters tab. Okay, great. So you can see our canary is Saturday, our baseline is Tuesday, and our existing production is Tuesday. So we have 3 different server groups, as I mentioned. All 6 of these are behind the load balancer taking traffic, and taking traffic equally. All right, so we go into our canary analysis. And I think this is a good time to go into how we set up our canary analysis. So it'll go through that. And while it's doing the canary analysis, because this does take time, in order to do statistical analysis, you're going to need some data. And gathering data takes time. So we're going to let that thing gather some data as we go and talk about how we configure this, this judge or this canary. So we can have different configurations. Now you want different configurations based on the types of application archetypes you have. So API, jobs, machine learning jobs, whatever it may be, you can set up different types. We're going to give it a name and a description. We're also going to talk about just one metric today, but you can have hundreds or thousands of different metrics that you can have the system look at. So you can also define groups. So let me define a group first here. So add a group. You can define a bunch of CPU-based groups, right? So maybe you want to have load times or load averages or CPU user or CPU system all under the CPU group. You can also have a different group called maybe IO. So if you're deploying a database or changes to a database and you want to make sure that the IO is actually staying consistent, you can put a bunch of, bytes in, bytes out, those kind of things, writes and reads all going into IO. So you can define these groups. And the reason you want to define these groups is really because you can start weighting them below. And we'll get to that in a second. So let's go back to our group 1. We're going to edit this. So the name is latency. We want to fail on either increase or decrease. Now this is what caught me. This would have stopped me from deploying. It would have been a big red flag that, hey, it's not getting better, or it's getting better, but it's not because of your code. So maybe you should really think about that. The criticality tells us whether it should fail the entire canary, whether it finds a number or not for that given time period, query type, PromQL. So we're storing this in Prometheus, and it gives us a bunch of different ways to query our metric. So we're going to do that there, and let's get into scoring. So the judge that we have here is what Netflix uses out of the box. It's a Netflix ACA judge, but you can create your own judge if you don't find this one sufficient in their pluggable judges. The next one is the group weight. So allows us to specify which groups of metrics matter more than other. So if you're an API, maybe response time is more important than not. If you're a database, maybe network connectivity or network bytes in and out is more important than not. And you can start weighting those to tell you how to kind of tune the scoring depending on how your application works and what its purpose and goal is. Going back to the pipeline, so now we have our configuration. Let's apply this configuration. So we've selected our hello latency configuration here. We're doing it in real time. The lifetime of this is going to be 5 minutes for demo purposes, but in reality, you're going to want this to go for 30 minutes or hours, depending on how much data you have. So that's going to be the number one important thing to think about. How much data are you going to need in order to make a decision that is statistically accurate, right? And depending on the application, the criticality of the application, you may want more or less time. The next is the delay. Now, for Java applications, you're going to want to probably have a 5 to 10 minute delay depending on how long it takes to start up and then how long it takes to really kind of warm up your caches. So depending on the application, some applications take 40 minutes or an hour to really kind of warm up. From there, the interval, how many times we're going to be running this analysis. In this case, we're going to run it 5 times because it's 5 minutes at one interval. The step is 2 seconds. So basically your aggregation, how the data points, how much you want them to be aggregated. The offset, which allows you, today we're doing a Canary analysis, but this will allow you to do an analysis that is more like a post-deployment verification analysis. So, hey, if today looks like this, what does it look like a week ago? These are where you're deploying them to. What are your server groups called? The scoring threshold allows us to determine under which conditions it fails. Anything over a score of 70, it will pass. And it won't ever fail. It will always fall into the marginal, which will always allow us to take a look. You can set this to, let's see, if we set it to be 30, that means that there's a marginal between 30 and 40, and then anything below 30 will automatically fail. So we're going to set this to -1 where it was before. We then move on to the manual judgment. And the manual judgment allows you as a human being to make an assessment as to whether to continue to move this pipeline or not. Then you can kind of retrospect later to say, okay, well, the Canary said this was bad. I thought it was good for these reasons. And then you can move on. Most importantly, after we do that, we're going to destroy our experiment, right? We're treating this as a true experiment. And when you have an experiment, you need to kind of clean up the experiment when you're done. And then if everything passes, then we'll actually start promoting this into production and start a production release pipeline where we depend on alerting and other metrics instead of canaries. So let's go to our pipeline. Let's see what's going on here. So actually our pipeline, it shows that this failed. So let's go here. And we can see that our result is low, that our canary is lower. You can kind of see empirically here that it is. If that doesn't work, you can always see the histogram. You can see that the histogram shifts the numbers over to the left a bit. And then we also show a B-swarm plot that shows us where the data points fall. And again, you can see that the median is indeed lower and also that the distribution is more spread out. So that's why I give it a low score and it failed it, giving it a 0. All right, so what I'm going to do is I'm actually going to say stop. I don't want this pipeline to continue because I'm going to listen to what the computer is telling me or what the analysis is telling me. So I'm going to say stop. Now you notice that the pipeline still continues because what we want to do is clean up this experiment here, clean up the baseline, and then we will not promote the prod. So let's look at that for a second here. We have the analysis that says it's conditional on an expression. It says if the manual judgment is not equal to stop, then we will continue with this pipeline. But it is equal to stop because I just pushed stop. And so we're done. And so it's cleaning it up. So if we go into our clusters view, you'll notice that the 2 other clusters have disappeared because we went ahead and cleaned it up. And so the pipeline has completed. We've cleaned everything up. It gave us a warning that we should have not gone to production. We didn't go to production. And everything has been completed. So that's my demo for today. There's a lot of ways that you can use this Canary Analysis engine called Cayenta inside of Spinnaker. I've shown you one of the most primary use cases that you can use in order to kind of verify whether your code going to production is going to be good or not. You're testing in production. You're all about reducing the impact, not just reducing failure. This was a failure that you just experienced in production, but it had a very small impact on the user base. And that's the way that we should be moving forward as we move into a more complex software world where there's thousands of microservices with lots of developers and many different failure reasons we can not all encapsulate into integration tests. So that's it for my demo. Thank you very much.